the three-headed hydra of Nvidia is really hard to compete with because, we saw the AI hardware companies, they tried to make a better hardware, but they couldn't beat them on, they tied them on hardware, let's say that, but they couldn't beat them on the software. And let's not, and then we're not even talking about the networking. So what happens is you have to beat them on all three vectors of competition at the same time. If you cut off one head, that's not going to be enough. You have to cut off all three at the same time, and each of the heads are at the top of the game, leading and getting better. So this is the hard problem, is that you have to compete with them on three different fronts, and most companies are lucky to be able to compete with them on one.
We're going to talk about AI, semiconductors, Nvidia, and what this all means for us today with Doug OLoughlin, author of the substack Fabricatedknowledge.com, which I've been reading religiously for 3 years. And had I put my money where my mouth is with what Doug has been saying, I would be a lot richer today than I am currently, because Doug has for years been writing about the interaction between semiconductors and the AI revolution, which we're all living through today. So in this conversation, I want to focus it in particular on Nvidia and talk about how this firm sort of rose to prominence and just how important it is to the large language model revolution we're currently living through, and what are the future corporate as well as policy implications of Nvidia being a $1 trillion plus seemingly indispensable to whatever's going to happen for artificial intelligence in the coming years. Doug, welcome back to ChinaTalk.
Thank you for having me, Jordan. I'm happy to be back.
Jensen Huang, born in Taiwan, moves to the U.S. at 4. In 1994, decides he wants to do computer graphics. Take us from there, Doug. What are the deep origins of Nvidia?
Nvidia first was truly like a fly-by-night thing. They knew they wanted to do graphics cards. There were a few other competitors, but the first name, actually, the origin of the company is NV, next version. They didn't really have a name for the company at all. They just called all their files NV, next version. And so at some point they have to incorporate, and then they're like, well, we're going to do Nvidia for the Latin word for NV, and they just did NV. So that's how the naming came around. That's how they first started. They were always just focused on the next chips. And their first chip they made in 1995 is NV1. And so this chip is pretty much just like a low-level graphics card to enter the graphics market. And so this is like, way back history. We're starting to add graphical user interfaces to computers. And so they partner with what is now STM today, and they launched their first chip. It's okay. They launched their second chip, which was a little better, and then they skirt bankruptcy, and then they finally launched this chip called Rivio 128. Rivio 128 was like their defining moment, and they started to, and essentially since then they've always been a juggernaut in the 3D graphics industry. At this point, they're kind of duking out with Silicon Graphics, 3DFX, S3. There's like a lot of other companies, but they don't matter because Nvidia and ATI, which essentially ends up being AMD, are the only two companies to make it through this like intense period. There were, tens of graphics cards, and Nvidia really was the winner of it all. So, at this point, 2000, 2001, 2002, they really become like the stalwart, have an amazing series of products, take a lot of share, usually at the high end of the market. And that really is the story of, I guess the beginning days of Nvidia from, a tiny fledgling chip company where they were fabless, and then they started to make new products, eventually won their place into the market share and became dominant and have held that position in gaming ever since. The transition into, and maybe I should talk about that right now. It's like the transition from gaming into AI.
Let's stay on gaming for a second. So Doug, I remember, shout out to PC Gamer in the 90s, sort of reading about all these graphics cards, and it was like Nvidia versus everyone else, and there would be these big spec battle, which I think is my sort of first introduction to computing. It must have been sort of watching like these, the real GL scores like go up over time. All right, Doug. So everyone wants green in their computers. Nvidia is the king of computer gaming, but that wasn't enough for Nvidia's leadership, it seems. So how did they take the firm to the next level?
So Jensen has always been very vocal about accelerated compute. Okay, so there's kind of an important shift here that I want to talk about and kind of just explain to everyone the difference between parallel computing and I guess the rest of computing. So x86 essentially, which is like the CPUs that you're familiar with, take instructions, they fetch the instructions, they do the job, they put it back. They do that very, very quickly. Um, GPUs are specifically meant for rendering each and every single pixel on your screen, right? And so each pixel and each color and the location and the change of it, it's a very parallel problem because, it's like, let's say 1080p, there's thousands of pixels and each of the pixels need to know how to move and how to change and whatever. So you can't just do this with the CPU because the CPU would be like, they'll be trying to calculate each individual pixel. You need this machine that is extremely wide, parallel, so that it could do all these little computations in parallel at the same time, and that's how you get a graphic interface, right? Um, well, those three pixels, those shaders, the calculating triangles, is best done by matrix multiplication, which is really important for AI. So the type of calculation that GPUs were meant for, which is the graphics processing unit, for the highly parallel to calculate all the pixels, ends up being almost a perfect use case for what would be the primary, the most heavy part of computing for AI. And so,
So, uh,
so now
so,
they kind
so
of,
Doug,
yeah,
let me just say, let's say on that part. Is it just a happenstance that what you need to render tribes to ends up being something that the deep learning revolution builds off of, or is there something more fundamental going on with this sort of linear versus parallel compute thing that it wasn't necessarily something that Nvidia just lucked into by dominating the gaming industry?
I would say a mix of both. They're definitely like the type of processor, right? Definitely ends up being well suited for the gaming, and it's like, look, there's this market that has a need that we can fulfill in the near time, and we can make money the entire way. But Jensen definitely clearly had his eye on the ball. Like he was talking about accelerated computing and AI and like, well, maybe not AI, but accelerated computing and all these things and all the workloads of the world needing to be sped up in like 2010s, man. And every year he would talk about it, and everyone's like, oh, that's pretty cool. And every year it would happen, but every year we would never really see it, if that makes sense. And Jensen the entire time was giving away the ecosystem. So there's a part of so the GPU is the graphics processing unit, but also how to make sure that your code compiles. Because remember, your code in like a big monolithic way is not used to running on a graphics card. It has to be split into small pieces and then be fed into the machine parallel, and then it can do it. So there's something called CUDA, which is I can't tell you what the acronym stands for, but the CUDA is the CUDA is like the software for helping parallelize. I don't know, make the product, make the code more parallel, and then be put into the GPU. And importantly, Jensen thought about this, knew that if he gave away the software for free, it would create an ecosystem, and started giving it away for free as hard as he could to all the researchers. I want to say as early as 2010. And so essentially he would just give away GPUs, give away CUDA, do all this stuff, and make sure all the researchers were working and using GPUs and only knowing how to do their problems on GPUs and optimizing their physics libraries the best they can on GPUs. And so what happens is Jensen kind of had an eye on the ball and knew that by creating an ecosystem and making it like the product to use, like I'm trying to think of a good example that's like a very consumer oriented one, but it's like if everyone knows how to drive a car, they're all going to drive this type of car, right? They're not going to go out of their way to learn a new type of, a motorcycle or something, right? So he literally gives away the car for free so that everyone knows how to use it. Everyone uses it in their workflows, and then everyone optimizes around it. He does this for like a decade essentially. And so as this improves, and Jensen the whole time too, like looks at these problems and knows that these like super massive multiplication problems are kind of the future of like big data, if that makes sense. Like I don't think that would be a spicy opinion that in the 2010s that you knew that what matrix multiplication would be used for very large data sets and very hard, complicated problems. That's not a big leap, but really pursuing that path, seeing that vision, and then kind of creating the ecosystem around it, giving away a lot of it away for free is how he locked in that ecosystem truly 10 years ago.
So, the Transformers revolution, what is that, and how does it connect to the computing power and software ecosystem that Nvidia built?
Yeah. So transformers are a specific type of a type of AI model, if that makes sense. So each transformer takes a lot of pieces of data, like, and let's say a large language model takes like a phrase, a sentence, and then it puts all the information that each word has to each other into this transformer cell. And what's important is transformers were, there's actually another type called RNN and CNNs, which is recurrent neural networks and convoluted neural networks. There's other types of neural networks. Transformers don't perform as well as they do at small size. But the one thing transformers did really well is they scaled up infinitely. And so what kind of came to happen was that we realized that with the transformer model, we could scale these models much, much bigger. And when we scaled them, they improved and they continued to improve. And so these transformers are like the tiny single blocks of compute that really makes these models possible. And within each transformer, and to train and learn and teach the transformer cell what it knows, you essentially, it's like a guess and check process. You go, the computer guesses the outcome, and you're like, well, check it against the actuals, and then it just does it over and over and over and over again until it literally has guessed and checked everything it could possibly guess and check between this data set. And it's like, okay, we've learned all the relationships by guessing and checking our way to figure out the answers. Now we could take these relationships, and whenever you feed us new information, we can use what we've learned from all the information that's been fed to us and give you a result. That's the transformer LLM breakdown, if that makes sense. And so all it's guessing and checking, lots and lots and lots of compute.
So Nvidia has two lines of revenue, gaming and data centers. Tell the story of the past quarter and what ended up kind of culminating in the questions that have been answered as to Nvidia's importance over the past few months.
Yeah, so the big difference, as you know, is that ChatGPT has become a viral and very meaningful product, right? I would say it's in the millions of users. It's still very small penetration as a percentage of the total. But the thing that's really important is that this AI thing has been happening for a while now, right? Like GPT-3 was really good, and as you know, if you use the G 3.5, it's a very good model. But I feel like we finally hit the tipping point of where it became truly a product that anyone could consume, and then once people started to consume it, they started to realize the potential. So and to be clear, it's still very immature, but one of the things that's really important about this whole story is that we have a roadmap for AI to get better, which is very rare. We were talking about the transformers earlier. We realized that transformer models, as they get larger, they improve. So what researchers have been doing is they've been making them larger, and they've been improving. And so now we're at the point where it's literally like, we need new GPUs so we can make larger models that we know are going to be better, and that's how we're going to improve. So going forward, and this is obviously the quarter for it, because the gold rush is on, the VCs are spending all the money, people are realizing the potential of ChatGPT and the right way to improve these models. And like there is a lot of engineering, there's a lot of like work being done at the data science level, but the biggest problem that is a big ticket item for anyone to really enter the game is a lot of GPUs. For example, there's this private company called this VC-backed company called Anthropic, and they literally just raised like billions of dollars, and they're like, we're going to spend billions of dollars on GPUs. And that's really what the big difference is that these like AI workloads. Let's compare AI workloads to traditional workloads. Like a traditional workload, like let's say hosting a website is like you would go, you load the website, and then the website, pings a web server. The web server tells you all the responses. These are really easy problems in terms of compute. But if you look at AI, it's totally different, right? Let's say you ask AI a question. What it does is, it runs your 30-word sentence into its model. Its model has billions of parameters saying, it's like, okay, tell me the relationship between all these words. Tell me what this means and what am I supposed to say back to it? And so it's each time you run a ChatGPT query, it costs cents, which is, that doesn't sound like a lot, but like in terms of compute, like, when you were Googling and stuff, like, it didn't round to a cent. And now each time you query something, it costs cents. And so people, the big difference is that AI is way more compute intensive. And not only is it compute intensive, we know it gets better with even more computing. And so everyone has woken up and said, we need more GPUs now. It's a war. And in order for us to win the war, the only way is to buy more picks and shovels and be pick and shovel providers. And so that's really what's gotten us to this point.
Yeah. So it's everyone understands that those cents, if deployed in the right way, can be dollars. But the cents are all going to be going to across, vertical after vertical Nvidia, because they're the ones who allow you to try to leverage these models into your existing businesses in the first place. So, Doug, let's talk about the sort of like different types of customers who are going to be needing Nvidia. So you mentioned, firms like Anthropic that are trying to develop their own foundational models. Like, who else needs the type of compute that Nvidia is selling?
So the big ones are Microsoft and OpenAI. That's the big company. But then also a lot of enterprises are starting to put real dollars behind this. Salesforce is saying, hey, we're going to add AI to all of our workloads. I think ServiceNow just did about big private cloud. So enterprises are starting to meaningfully move forward because as much as anyone wants to just give away the keys to the kingdom to OpenAI, because OpenAI is truly the best product right now, a lot of companies, especially tech companies, are going to want to do it their own and have some kind of proprietary difference. For example, Bloomberg made a Bloomberg GPT, which is only trained on financial data, much smaller than the OpenAI GPT, but it's actually better at just finance because there is specialization. So what's going to happen is everyone wants to make their own, bring their own data sets and make their own models that are built on just their proprietary data set that should outperform what is publicly available. So this is kind of the gold rush era, if that makes sense, where everyone is trying to figure out how to best make a model, how to best scale it, and how to make it their own. Nvidia actually even sells like essentially a managed service to train your own model. But everyone, Meta is a good example. So right now, most of the core investing is coming from these really big companies at the top, trying to provide and create the solutions that will probably try to scale to sell as products to other companies, individuals like us, and et cetera. And the thing that is, no one really knows where the limits of improvement end. And right now, OpenAI is clearly in the lead, but it's one of these things where it's so dynamic that the lead is definitely not guaranteed. So everyone has to invest into it. I mean, I think Sam Altman said something insane like, to make OpenAI viable, we need at least $100 billion. Like, that's crazy, right? But we know that the models get better if we make them bigger. And so the only way we can make them bigger is if we buy a lot more GPUs. And that's kind of where we're at right now.
All right, let's talk about competitors. Nvidia can charge enormous margins because they're, to a certain extent, the only game in town. But there are lots of other folks from the likes of Cerebras to Google and Microsoft themselves who tried to design their own chips. So what are the other approaches, and why are they not as good as what Nvidia has on offer?
So I really think there really is only one real competitor, and that's Google. And so one of the I actually just wrote a piece about this called the three-headed hydra. Like, there's coming wave of AI, but I talk about how like this three-headed hydra of Nvidia's like competition. And so Nvidia has three important parts of the stack extremely locked up. One is the hardware. The other is the software with CUDA and all the optimization around it. And the third is like the networking and systems. And so actually the order from smallest to largest, the software, hardware, the networking. So software is really important. For example, Cerberus is a hardware competitor, right? Well, when they started to make these hardware solutions, one of the problems that every single one of these AI accelerator companies started to run into was, we don't have the software to support the problem. So essentially they're like, wait, we have to build it. We have to build a software stack out of the box every single time if we want to do a new problem. And I guess in that view was that AI was going to be relatively fixed and people would know what would be the, kind of like the right answer. But what actually ended up happening is the world was so dynamic, things changed. The GPUs kind of GPUs are better than CPUs, but they still are flexible enough to kind of be used for any matrix multiplication problem. And so a lot of companies actually made the bet on convoluted neural networks. But then what happened was the transformer model came and completely blew them away. So a lot of the AI startup companies, the hardware startup companies, had a good hardware solution, but they didn't have a good software solution. Meanwhile, there's also another level in this, which is called the networking thing, because on top of having some hardware, what's happening with these models is they're becoming so large. Like, you can't, you go and buy a $40,000 GPU, right? that's not going to be enough to train your model. That'll take years to train them, or I don't know, I can't months to train like a small model. And these really, really big models, they take months to train, and they're being trained across tens of thousands of GPUs. And so one of the problems is it's called the interconnect problem. Is it's not only how good the the hardware is, it's how good the hardware works together in a big system. The analogy I use is that the pizza is too big to bake in any single oven. So what's happening, but in order for one cohesive model, aka pizza, to be finished, you have to cut each pizza into these tiny little slices, and each oven is meant to cook just that slice, and then at the end, it's put all together into this giant cohesive model. Um, there is an advantage there called NVLink, and there's a lot of software optimization too in order to scale up these models so that it's larger than just a single GPU. That is something that Nvidia has, that they've done a really good job at. That I think the AI hardware companies really hasn't offered a good solution. Now, there is one other competitor in town, and that company is Google. Google has been on the forefront of AI research for a long, long time. And they have a lot of the aspects and things that that Nvidia has, but custom and in-house. And it's proprietary. They don't really sell it as a solution. So TPUs is their hardware, XLA is their software CUDA kind of layer, and they have their own like OCI networking product. I can't remember what it's called, but they have this whole solution, and they have the models on top of it, and they have the customer facing it. So Google right now is probably the closest real competitor that has a complete vertical full stack, versus Nvidia doesn't have a full vertical stack because they're not customer facing, and they don't really make the models. Like they make some open source models. They obviously improve the entire ecosystem, but they're essentially AI as a service, and they're trying to sell it to people who are actually making the models, versus Google is trying to own the entire stack, consumer to model to hardware to networking, and sell it to them. And so far, Google has truly the most competitive differentiated offering relative to Nvidia, but no one else has really made the solutions like Nvidia does. And there's a big difference between making a theoretical chip that you can maybe solve a model according to according to the spec sheet, and then you take the chip and you try to troubleshoot it, versus Nvidia. You could buy 10,000 GPUs and it will work out the box. That's a big difference. The productization and how Nvidia has done a really good job at making a product to sell to customers. That's their big differentiator in my. And to bring this all back together, the three-headed hydra of Nvidia is really hard to compete with, because we saw the AI hardware companies. They tried to make a better hardware, but they couldn't beat them on. They tied them on hardware. Let's say that, but they couldn't beat them on the software. And then we're not even talking about the networking. So what happens is you have to beat them on all three vectors of competition at the same time. If you cut off one head, that's not going to be enough. You have to cut off all three at the same time, and each of the heads are at the top of the game, leading and getting better. So this is the hard problem, is that you have to compete with them on three different fronts, and most companies are lucky to be able to compete with them on one.
So, Doug, we haven't mentioned China yet. And of course, in October 2022, there were export controls which were put on China by the U.S. Department of Commerce, explicitly to stop PRC-based data centers from being able to acquire these sorts of full stack of NVIDIA compute, which has made them so much money over the past few months. So, what are the implications if it's really a two-headed race with Nvidia and Google, and there's no Chinese firm that ends up emerging to compete domestically with the sort of compute offerings that are going to be on sale outside of China for years to come?
Yeah, so I would say maybe the only company I've heard of is Biren, the GPU company, but truly it's a product that's like super behind. One of the benefits of this is that the U.S. for better for worse definitely seems to be ahead in the innovation game, right? Like, and also the GPT problem. It seems like there's like a censorship problem. So while we could run unfettered fast and as fast as possible, China just doesn't have the engineering chops, and importantly, the October export controls kind of stopped their ability to even do that. So remember, they can't make the chips. Everyone is relying on TSMC, and we've done as hard as we can to cut them off on their ability to do that. So on top of that, they can't really design the chips. I think some aspects of the EDA has been turned off for them. And so all in, and what we did on top of that was we limited the networking aspect of it. And so Nvidia can sell chips to China, and they do. They probably sell millions and billions of dollars worth of called H800, and what that is, it's essentially a gimped version of the H100, where it has much worse network. And so I think the specs are kind of similar. It's probably like a slower bin or something like that. But the department, the BLS department was really thoughtful and was like, okay, well, we can give them as many hardware, as many chips as they want, but they can't scale up to make these ginormous models if they don't have the networking. And so that's how the United States has really hampered and cut off the ability for China to be even in the race. So I'm sure there are domestic companies that are trying to essentially get around this problem because the chips are the same. I'm sure there's some way to improve the networking and be able to scale it out into an even bigger, better way. But at the same time, it's just not going to be what is available off the chip today. And so it's just really hard for me to even imagine China competing on these large language models because they have, their hands tied behind their back, truly, because they don't have the ability to scale up to this huge amount of. So maybe they could scale up with even more H800s. It would just cost some ridiculous number that is truly mind boggling. So, and that's just, in the race to buy NVIDIA GPUs, and there's essentially no real domestic competitor that has any kind of shot. I mean, US competitors right now are still seem to be years behind NVIDIA. So that's how I kind of think about the Chinese ecosystem. And truly, they're pretty handicapped. And if I was a Chinese regulator or a Chinese AI guy, I would be pretty pissed.
So there's Chinese firms, however, are not restricted in accessing cloud services overseas. So there's really nothing today stopping, a Chinese company from buying the top of the line NVIDIA compute from AWS or what have you.
Mhm.
Is that like annoying at all? If you're a firm and you have to rely not on Alibaba Cloud, but on Western clouds, or even Alibaba Cloud based in Singapore that can still buy as many A100s as they feel like. Is that does that end up mattering all that much as long as that window is still open for these companies?
I think it matters quite a bit. I mean, it's kind of relegated China to being a consumer, a purchaser, a seller. Like they can only buy the IP, but they can never own it, if that makes sense. We're trying to lease the future to them, and which sounds really profitable and truly is, if that makes sense. And I think that the cat's out of the bag, the fact that China really cut off the West to their internet. So we're like, okay, well, we're going to cut you off to all of the AI research, all the AI hardware, and now you're going to have to buy it as a service from us. So I think that there's kind of like this tit for tat, and I think that it's really hard to imagine anyone truly competing.
Yeah, it's an interesting thing, Doug, because you can't compete then on the hardware level, right? If you're sort of locked up from all this stuff. But if you as a consumer facing or like an enterprise, or some B2B firm, you end up training your model on AWS, and you have a product that's competitive with Salesforce, then like you can compete with Salesforce, right? And so we talked about you're spending pennies in compute on queries, hoping to get dollars of revenue back, and it's an open question whether it will it is the right strategic calculus for America to allow Chinese firms to develop these capabilities. Even if they'll never be able to, even if they'll still sort of remain dependent on overseas compute and never really be able to domesticate the semiconductor ecosystem as she clearly wishes he could.
Yeah, I don't know. It's pretty hard, I guess. So yeah, maybe hopefully they can spend pennies to get dollars, but realistically, if I had to guess, they're gonna be spending pennies to make 50 cents. So it's going to come in at a lot lower margins than it used to be. And I think that's a big deal. But once again, if we really are, if China and US really are these like ideological, the ideological trade, mind, whatever war going between these two countries, why bother at all? And I think that today's version of how this is working out, it seems like we're closer to the why bother at all. And truly being cut off to the future like this would make me, if I was a Chinese regulator or whatever guy, Politburo member, I'd be very, very pissed. I mean, it is very strategic, as we all know. AI is going to be a very important thing. I know it is very nascent. There is a lot of hype, and I think some of the hype might be getting a little hot. But at the same time, you roll it all together, we really have cut off the future of humanity's roadmap of progress in terms of technology doesn't seem to be available to China in scale. There's a lot of ifs, and even then, even if you can, get the GPT-4 or whatever, some of the, in theory, the future of how this really plays out and it becomes really valuable is everyone gets access to this big model and they get to use it for themselves. And I think that it just seems like China is completely left out of the picture altogether in terms of it's the same kind of technological, theory behind how we restrict their semiconductors. Oh yeah, we'll let them have something that's 10 years old. That's how it kind of feels, if that makes sense. And there was a race between China and US for AI, but it definitely, the hardware aspect that we hampered their hardware really cut them off of their ability to scale. So
Yeah. Yeah. I mean, it's an interesting question, right? And it sort of like puts the lie to the thing that Jensen Huang's been saying on TV, that like, oh yeah, like if we don't let Chinese firms buy semiconductors, then like we're gonna fall behind. But it's particularly not the case if Chinese firms are sort of using compute, but instead of housing it in Guizhou, they're just like using it in server farms in Seattle and Singapore. But
mhm.
it is a sort of broader philosophical, I don't know, nature of the competition policy question, like whether or not the U.S. Is going to be comfortable with China, with Chinese firms having relatively unfettered access um, to these hardware stacks, but just outside of the territory of the PRC. And I think that's it's definitely a debate you'll start to see heating up. There's
S-
already been some.
yeah, I.
Um,
I didn't realize that they could buy from essentially across the ocean to Singapore or something. But the
yeah,
important part of this whole thing is latency is really important, right? Because they can use ChatGPT or whatever, but just the raw latency of it is going to be a lot slower. Instead, in the United States, we get to use it. We get to 60 millisecond whatever response back. For them, it might be a second, 2 seconds, right? And so sure that some consumers will be able to eat that, but I guess the fear is that like in terms of like technological like warfare, for example, they'll always be cut off of the super high end stuff because it has to be done. The latency is a really important part of it. But yeah, I don't feel like that's going to fly, that the US is going to let them rent models from US companies.
yeah. And we've already seen restrictions, like open ChatGPT is only available like, it's not publicly available in China. I know there's like plenty of Chinese content creators, at least online, who figured out their way to spoof a phone number or whatever. But having this stuff not be available at scale is something that is obviously having an economic impact. And the sort of justification is that if something awful happens, like you're not going to have hopefully like AWS knows what's going on their servers enough to stop a sort of like a Chinese drone swarm invading Taiwan via their sort of like cloud compute in Singapore. But
Yeah, I
yeah,
I would think they're aware enough, but on top of that, even if the drone swarm was, um, I'm assuming like the closer compute cluster is going to win because one's going to be faster than the other. And so if you have to lease it, like it is a physical problem, right? Where it's like, hey, if they're renting these AI models in Virginia or North Carolina, wherever the giant server farm place is, that's going to be 600 millisecond latency versus if you're running it locally in Taiwan, the faster one will win. So I I do think, I don't know. I'm pretty curious, and I would guess that these kind of like drone swarm questions are going to be a really interesting future one. I'm sure like the United States is clearly trying its best to adopt as much intelligent stuff into into the weapon systems of the future. But if it can even be done like from a swarm level, like via cloud, I feel like this doesn't even make sense. So yeah, it's going to be interesting. And my gut says the United States government will stop their ability to do that, right? Or they'll have a restrictions list as well.
Um, so Doug, speaking of sort of like bringing the bringing compute to the device, this is sort of the dream, right? Is you don't need to use supercomputers, that you can just have it on your PC or your iPhone or your, smart glasses or whatever the hell we're going to be doing in 2030. To what extent is this sort of bringing the inference down to the device a threat to Nvidia's future?
You're right. The most ideal future is that, hey, everyone has their own chat GPT, their own whatever this, and like chat GPT is generalizable. That's one of the, or GPT is generalizable. That's one of the big benefits of it. It'd be on your phone or your computer, but so far it just doesn't seem like that's going to be the case. So inference will probably be done, like there will be lower quality inference being done on the stuff like that, where it's like dumber, if it makes sense, where it's like, hey, photo recognition. Photo recognition, for example, your face recognition on your phone, that is an inference problem, and that is solved on your phone without, without the cloud stuff. But the really high end cutting edge models seem to be done in these ginormous data sets, like these data sets that, the phone, it's going to take a decade or two of improvement of phones in order to get to ChatGPT 4, for example, right, on your phone. It's going to take like a decade to get there in terms of the size of the model to be able to be able to host it on your phone. And so right now, the desire to have on device inference is really high, but so far all cutting edge models are being done in the cloud because a lot of these emergent things are only happen when the models become super 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 big, right? So it's kind of like the difference between a fifth grader's English and a college professor's English, right? They both are speaking English, but whatever that difference is very, it's minute, but it's a big difference, right? And so we're not going to be able to see any cutting edge models that have these like really amazing things like the true aha moment. For quite some time on the device. So
Doug, let's close maybe by thinking about sort of Nvidia as a from a public policy lens. We have the CHIPS Act, of course, which is about to spend tens of billions of dollars, both to sort of bring fabrication to the U.S., but also hopefully to sort of help kickstart the next generation of whatever hardware company that turns into the Nvidia of the 2030s or 2040s. What lessons from Nvidia's arc should policymakers take as they're thinking about what is necessary for the country to cultivate that next generation of firms?
yeah, this is a hard question because NVIDIA's history truly is a little bit like being in the right place at the right time, creating a GPU, and then creating that logic and being like, well, if we can do this in the future, we'll be able to do this. It kind of reminds me of like, have you heard the Reed Hastings story, the Netflix guy? He's like, hey, we're shipping DVDs, but one day we'll be able to stream on the internet. That long-term bet is really what Jensen made a long time ago. It seemed hard for me to imagine another company making that kind of a long-term societally changing bet. But Nvidia for its entire life has been duking it out in the graphics, the GPU market. And I would say that like the competition that happened in the US was probably good for it to improve its product and create a roadmap. Choosing winners usually never works, and Nvidia definitely won the right to be the king of GPUs. But the hard problem with this whole thing is that Nvidia was always a fabless company, so they kind of got to ride on the coattails of TSMC. So there's this like weird public, use problem where we have this ginormous, like they were able to be so innovative on the back of the TSMC's massive societal improvement by creating this open foundry for everyone. And I think that that's probably the biggest lesson for public policymakers because the story of NVIDIA probably wouldn't be able to be possible without the story of TSMC. And the story of TSMC obviously is a foundry that is stranded for intents and purposes and 100 miles the coast of China. And so having that availability and having that ability to create that platform at the bottom of the compute level to then enable other companies to build on top of that, I think that's really important. I think that's what we're trying to solve with the CHIPS Act. But frankly, the CHIPS Act is helping, but is it enough? We're going to see. And there's actually a series of headlines I think is really interesting right now, talking about how Nvidia is actually seriously considering taping out at 18A for Intel, which would be a huge win for the West, if that makes sense. Is that, hey, all of a sudden we have these GPUs that are being able, these super important GPUs that are like the most strategic thing that you could possibly want out of a compute today, and it could be fabbed in the United States off of Intel's process. I think that would be a huge win, and it's something that that people who are close to space are all watching and waiting for. Also because Intel's 18A process is an important inflection node for Intel as well. So I think that's the takeaway is that NVIDIA was enabled by the fact that there was a foundry that could do everything they wanted, so that they really were able to focus on the market, to focus on the innovation, to focus on the design, while TSMC took care of the rest. I think that having that public asset is really important. So that's my takeaway. I don't know. Would love to hear your thoughts on it as well.
Yeah, I mean, I think there's also a sort of story of founder-run companies and the choices and long-term bets that Jensen and his team were able to make it's just not possible unless you have the sort of cachet that you do as the person who's fought and won all the battles over the past decades.
Jensen is one of the longest public CEOs in as far as I know, right? He founded the company in 1994 or something like that. It is 2023. Zuckerberg obviously did Facebook, and the Google guys are out of there. I think he's the single largest public company CEO who's still at the top of his game. And what's amazing is that after 20 years, you sometimes people miss the boat and they get less good. You cannot say that is the case for Jensen. Jensen has definitely been on top of the ball the entire time. He's been talking about accelerated compute for a decade, and he's been talking about all these societal changes, and look, it's happening, and he's been right the entire time. We should have listened. I mean, that's kind of the thing that's really amazing is like Jensen has been right. He's been right with a long-term vision that is so rare to see, that truly being able to see 5 to 10 years in the future, very, very, very rare, and Jensen did it. So I think that's a really important thing, is like being able to give the founder the capability to run the ship like they should, because Jensen obviously was focused on things along the way, but he was always steering to this long-term target on the horizon. And I think that's really important as well.
We talked on another podcast about James Glick, and I feel like there should be like a James Glick chapter on NVIDIA, when he hopefully writes his AI book, about just like how kind of like absurd and beautiful it is that a company that was built to allow, teenagers to play video games and render Wolfenstein ends up being the thing that like ushers in an entire industrial revolution. And there's something like really like wonderful and human that us just wanting to play games that were more realistic ends up turning into this incredible thing that's going to change not just gamers but all of our lives.
Yeah, there's something beautiful about play, right? It's something, we're social animals and we play, and that's really cool. And also, speaking of James, like I'm literally reading the information right now, rereading it, because I think it's very applicable. I think that one of the things that may be a little underappreciated is that AI in a lot of ways is like an information compiler, right? Because and like Jensen's keynote talks about it. It's like, hey, you can take any amount of data that we know there's a relationship, and we can put it into another form of data, right? Text to video, video to text, whatever, but also like text to DNA. Like we could ask ChatGPT right now to go write a song about, write a chip song for ChinaTalk and transcode it into DNA sequences. We can do that. Like, isn't that cool? Like all information is able to be translated into all information because of AI. And I think that's really cool. A universal information compiler. And I think that, we're going to, obviously we're a little hot right now. Things are a little peaky, a little bubbly, a little bubblicious as people are freaking out a little bit. And I'm aware going on a podcast is definitely not a good sign of that. But the societal changes of this is going to be a big deal. And I'm really excited for the James Glick book, as well, is what I'm trying to say.
Doug, thanks so much for being a part of China Talk.
Yeah, of course. Happy to be here, Jordan. Nice to see you again.